What's going on, guys? Mr. Allen here. We're about to solve a system of equations and not any ordinary one. All right. This bad boy has non-linear equations. That top equation there, that is the equation of a circle. That bottom one is a parabola. Now, we can really use any one of our three methods, whether it's graphing, elimination, or substitution. Generally, we will favor the elimination or substitution to do it algebraically. And for this particular one, even though we could do it either way, I'm going to go with substitution method. So I'm going to take this bottom equation here, the x squared minus 2x equals 3, and I'm going to solve for x squared. And the reason why I'm going to do that is I see that I have x squared in my top equation. I can just substitute whatever I get in for that. So I'm going to add 2y to both sides, and I'll have 2y plus 3. So I'm going to take that 2y plus 3 that we have right here, and I'm going to substitute it in place of x squared. So I will now have 2y plus 3 plus y squared equals 27. It gets plugged in for the entire x squared. Right? If this was just x equals 2y plus 3, then it would be quantity squared. But because it's x squared and I'm substituting in for x squared, it looks just like this. All right, so now I have a quadratic that I need to solve. The way I'm going to do that is by setting it equal to 0. So I'll have y squared plus 2y minus 24 equals 0. Right? I subtract 27 on both sides, rearrange. Now I got to factor. What multiplies to negative 24 and adds to 2? Well, that would be 6 and negative 4. Boom. Now I can set each one of these equal to 0, so I'll have y plus 6 equals 0, and y minus 4 equals 0, and I'll get y equals negative 6, and y equals positive 4. So these are my two possible values for y. Now the reason why I say possible is because I don't know if both of these solutions are going to give me real x values when I plug back in to solve for x. So let's go ahead and see what happens. So before I start going ham on plugging in, what I like to do with these problems is I'm going to go ahead and either, if it's a test, I'm going to jot this down on my answer line, but I'm going to keep it up at the top here. We have negative or something comma negative 6 for a possible solution and something comma 4 for my other solution. This way I can, like, as I work through these, I can stay organized, right? If this was an answer line, I'm going to pop that down in the answer line, okay? So let's start with that negative 6. Which one's going to be easier to work with? Really, either one's cool. I'm going to take the bottom one because there's less going on in my opinion. So I'm going to have x squared minus 2 times negative 6 equals 3. So that means x squared plus 12 equals 3. And I'll have x squared equals negative 9. Well, if I square root this, now I'm going to get x equals plus or minus 3i. Right? It's an imaginary solution. So this is not going to be a real answer here, not going to be a workable solution because we're looking for where these graphs intersect, right? That's really what the solution to a system is where they intersect. So that one's not going to work. So cross it out. All right, so my next one here, if I plug in 4, I'll use the same equation. Doesn't matter which one I use. So I'm going to have negative 2 times 4 equals 3. And then I'll have x squared minus 8 equals 3. So x squared equals 11, square root. And I'm going to get x equals plus or minus the square root of 11. So plus or minus the square root of 11. There is my final answer. Positive root 11, comma 4, and negative root 11, comma 4. Or you can write it with the plus or minus root 11, comma 4. That's it. We all done. But before we're completely done, I think it'd be nice to make sense on a graph of what this actually looks like. So that that top equation we said is a circle, right? So if I draw a circle, and that radius is the square root of 27, which is just over 25, right? So a little more than 5. But let's just say this is like about a little over 5 out here, right? And I'm just going to draw a circle. Yeah, okay, cool. Now the other one is a parabola that is opening either up or down because our y variable is the non-squared term. Now, if I brought that y over, really the equation I need to look at is this one right here. It's opening up, right? My vertex is going to be somewhere down here for this particular one, and it's going to be opening up. We don't have to get into y. It's going to be down there. Main thing is that, okay, we have two solutions here, right? My y value is the same. It's at 4, which is a little bit below where that, right, the radius of the circle is. And it hits right there and there at plus or minus root 11, which is a little over 3 on either side there. Cool? So I think that graph makes a little more sense as to what's going on here, why we only have two solutions. We don't have that other set of solutions there. It could happen if this graph was lower. It could intersect 4 times into the graph of a circle. But in this particular one, because of how it's positioned on the graph, we only get 2 real solutions. All right. Hope that helps. You guys have an awesome day. I'll see you later.